Hello everybody, today we're going to solve the bank customer churn problem where we need to identify which customers are about to churn and which are not in this bank. And this is a problem that many organizations are facing and trying to solve. And this is a B2C problem, okay, in this case. And okay, let's start and read the columns and try to understand what information we have here. So we have the customer ID, the surname, the credit score, the geography, the gender, age, and so on, and which are the predicting variables. And we have the exited variable, which is the predicted variable, our labels, whether or not the customer left the bank. Okay, let's go to the code. And wait, let me dive in, let me go up. Okay. First of all, this is our data set. We have, these are the columns that we saw, gender, age, and we have the exited variable, which is the predicted variable, which are ones and zero. This is a classification problem. Okay, let's continue. Okay, this is the modules, pandas, numpy, and so on. We have the train and test split for a model, the one hot encoder and the ordinal encoder for categorical variables, the min-max scaler to scale our data, and SMOTE as a technique for dealing with imbalanced cases. We're going to see soon that this is an imbalanced case. And this is an oversampling technique that we're going to use to deal with it. And we have the random forest classifier, which is the classifier that I'm going to use. And we have some evaluation metrics, precision score, recall score, F1, and classification report. And we have yellow brick to visualize this evaluation metrics, which is discrimination threshold and precision recall and curve. And also these visualizations can help us figure out how to improve our metrics. Let's see later. Okay, here I'm reading the data set, and here I'm just doing some descriptive statistics and basic statistics using the describe method. So if I'm just using the describe and leaving the inside blank, we're going to get all the numerical variables that Python think that they are actually integers and floats. So we have the row number, customer ID, age, tenure, balance, and so on. And we can consider distributions, their quantiles, the standard deviations, the mean, and so on. And if we've used the describe with the include equals objects, we get all the non-numerical variables so that Python identifies, which are surname, geography, gender, and car type. For example, for geography, we have 3 unique values, different values. The most frequent value is France with 5,014 examples, values. Okay. Now we're going to check for missing values. We see that there are no missing values here, so it's easier for us. We don't need to use it. Missing values technique and dealing with missing values in our pre-processing. Okay. Now I just want to make sure that every customer only appears once, meaning that each row is a different customer, because if we have more than one row for each customer or for some customers, we need to figure out how we can aggregate these rows together. Maybe we can use a group by and then aggregation techniques such as summation or average and so on. Okay, now we need to. Now I'm going to group features to categorical and numerical values. And then split it to train and test. So first of all, I'm going to remove customer ID, row number, and surname. And I didn't mention here, I think I mentioned it above. And if you'll see, I'm also dropping the complaint column. And that is because complaint column, the correlation between complaint and the exited, our target variable, is almost perfect. And that means that something is suspicious with that column, and perhaps they are very connected because perhaps a customer got a survey where he could complain to the company before he exited, and there is a very unexplained connection that we don't know about it. But so if we do use this complaint column in our model, we can get almost a perfect score because they are highly connected and correlated between each other. So this is unrealistic and this is a red flag, so we're trying to avoid it, so I removed it. Okay, let's continue. Okay, this is the target variable. Exited, this is the categorical variables that I identified. Geography, satisfaction score is active member, has credit card. And the non-features are all the rest of the columns. Okay, then I use the XY, XTrain, XTest, YTest, and YTest. And I use the test size equals 0.2. And I also use the stratify method, which is I want to keep the same distributions and proportions of the predicted variable in the training dataset and in the test dataset, and that is because we have an imbalanced case here, and we want to have equal proportions, more or less, between these two groups, because it can happen that one group, one dataset will have all of the minority and the majority cases, the churn cases, and the other group, there won't be anything. So it is a problem for us to understand if we predicted it well. So we're going to use the stratify, and that's it. I'm just validating myself that the split is well. Okay, now we're going to use exploratory data analysis. This is the plot of the predicted variable. We see that we have 80% of the customers didn't churn and 20% did churn. Okay, so this is the imbalance we have here. Okay, now I'm plotting some distribution of the categorical variables. Okay, we don't see anything highly imbalanced that requires something from us. Okay, let's keep up. This is the numerical variables. And I also added the skewness and the kurtosis to see if they behave well, if there is a skewed column, skewed variables. And usually the skewness should be between -1 to 1, and also the kurtosis. And we see, for example, that age is a little bit skewed to the right, and you see there are more variables that are skewed to the right, more older customers. Okay, let's continue. Here we have a correlation matrix, and we can see that there are no correlated variables between the correlated numerical variables, except for very low correlation between balance and number of products, a negative correlation. Okay. Here we have, here I'm plotting the target variables versus the categorical predictors, and we see that, okay, in this plot we see that the green bar is the number of customers in Germany that left, that churned, and the whole blue one is the ones that didn't churn, didn't leave. Here is the overall frequency, and this is the odds ratio exited divided by non-exited for this column. And this can help us understand if we see something interesting here. For example, we see that in Germany, there are much more customers that are churning as versus the other countries, Spain and France. So this can help us and give us a little bit more information of churn customers. Okay, so we see that it's more frequent in Germany. Okay, let's continue. Now for gender, we can also see that female are churning more than male. Okay, also interesting for us, and we know that maybe gender can give us a more predicting power later. Distribution of card type versus exited. We see that the numbers are more or less the same, so that means there's nothing interesting probably here. Okay. Also satisfaction score odds ratio, nothing interesting here. And now is active member, we see that non-active members are churning more than active members. Okay, good to know. This can also help us later. Distribution of has credit card versus exited. Nothing interesting here. The numbers are more or less the same. Okay, let's continue on to predicted feature with numerical feature. Okay, in this case, we have the distribution, two distributions of credit score, one for the churn customers and one for the non-churn customers. In this case, for credit scores, the distributions are more or less the same, so there isn't something very interesting or difference between the groups, between the credit score, in terms of credit score. Here, though, in terms of age, we see that customers that churn are more older, or distribution is more to the right, so they are more older than non-churning customers. And here we can see more and more stuff, but there isn't something very, very interesting beside of age. Okay, let's continue. Okay, pre-processing. We're going to use one-hot encoding for nominal categorical features, and we're going to map or encode the ordinal categories features, and we're going to use min-max scaler. Okay, here is the code for the one-hot for the categorical, the nominal categorical variables. Okay, you can check it out later. And this is for the ordinal ones, which I'm only using for the, you see silver, gold, platinum, diamond is the credit card type. Only this one. Okay, and then I'm going to use min-max scaler for this example. And I'm using this before using the oversampling technique. And that is because most of the oversampling techniques are using the KNN algorithm to generate more data. So, okay, KNN methods are distance-based methods, and they are highly dependent on the scaling of our data set. So that's why we're doing min-max scaler before we use it. Okay. So here I'm using the smooth methods with KNN was equal to 5. As you can play with it and see if it changes things. Okay, I think this is the default. Okay, for modeling, I'm going to use random forest classifier, and here I'm predicting the results, the test dataset, and we have, and I'm predicting the F1 score, recall, and precision. We see almost 61% for F1, and we also can find it out in the classification report. As you see, F1 score is 61%, and precision is 63%. And this is basically what it returns to us. Okay. Now I'm going to use the discrimination threshold from the yellow brick module, and I'm going to try and maximize and optimize my F1 score. So if I want to optimize, if I think that F1 score is the best metric for me in this case, and I'll try to maximize it to get the best result I can. Right now it's 61, maybe I can get more. But let's see if I can. And if recall or precision are more important to me, I can just change it in the Rmax here and see if I get something else. Okay, so basically what I see here is the F1 score in the red line, precision in the blue line, and on the green line is the recall. We have the threshold, which is like optimizing the best threshold to choose to optimize my F1 score, for example. And you see the threshold is 0.52. Usually the default threshold is 0.5. So I have it here. And if I want to optimize recall or precision, I can also use the precision recall curve and try to see which recall I want to choose and which precision I'll get. Because there is like, if you get a better recall, you most likely get a less better precision. Because there is a trade-off between the recall and the precision. So if I want to optimize the better recall, I know that I may get a less better precision. So that can help me. For example, if I'm satisfied with 0.6 recall, I know that I'll get almost around 0.6 precision. But if recall is more important to me and I want to have 0.7 and to show it to my manager, I know that I'm going to have around 0.5 precision. So these are the things that matters to us here. Okay, thank you very much.